cases where we have to be somewhat conscious to find out what is the N factor, right? I have selected 4 such cases. Fine. Come to case number 1. In case of case number 1, he is saying 3MnO4 minus. See that stoichiometric coefficients are also given here. 3MnO4 minus gives you 2Mn2 plus Mn4 plus. That's all. Now, listen carefully. Listen carefully. No one should go to chat box. Be on the screen. Manganese plus 7 oxidation state. Manganese plus 2 oxidation state. Manganese plus 4 oxidation state. Plus 7 to plus 2. Gain of electron. Plus 7 to plus 4. Gain of electron. Just wait a minute, beta. I'll come back. Now, once you're having this one, then, sir, both are reduction reactions. Plus 7 to plus 2, gain of electron. Plus 7 to plus 4, gain of electron. Then how to proceed further? Sir, already we have done so many examples of multiple oxidations. Yes, but here in this case, the problem is when you say that 2 different elements were there, here we have same element and enjoying 2 different paths. See, it is reduction via 5 electrons. It is reduction via 3 electrons. These 2 are different things. Therefore, in such cases, what we have to do? Very simple, sir, analyze. What is analysis of this question? Sir, there are 3 permanganate ions. Out of 3 permanganate ions, 2 permanganate ions are enjoying this journey. 1 permanganate ion is enjoying this journey. Okay, that is the way which we have to separate them. Okay, come on. First is 2 permanganate ion. Gives you 2Mn plus. This is first reaction. Second reaction, remaining 1 permanganate ion, remaining one, remember, remaining 1 permanganate ion is converting itself to Mn4 plus. 3 MnO4 minus, out of 3, 2 moles are enjoying this journey and 2 moles. Actually, what I have written here in this case, 6 plus he has given. No problem. I think I am enjoying example number 2. No problem. Example number 1, you people are genius. Come on. Now what to do? Very simple, sir. Change in oxidation state of this, change in oxidation of this one. Simple. Okay, how to proceed? What is the oxidation state? It is plus 7. Therefore, final oxidation state, listen carefully, 2 plus 2, 2 into 2. Here we have plus 2. 2 times manganese are available. Total charge. Total charge. This we have not done in the previous examples. We have not taken stoichiometric coefficient. There was no stoichiometric coefficient also. See the example 14, 15. Like that we have taken 1 to 15 all examples. So here in this case, plus 2 into 2. 4 minus final minus initial 7 and 2. 7 plus 7. How many? 2. Therefore, 14. Sir, valency factor cannot be negative. Okay. Make it mod. Right? Are you able to understand? First, separate path 1 and path 2. Both are reduction. I should not say reduction half, oxidation half. Path 1, path 2. Path 1, total charge on the products minus total charge on the reactants. Total charge. Then mod plus, come on, come here. 4 final minus, it is what? Plus 7 as usual. So what is that? This is 4 minus 7. No, sir, it should be dash. Nice. 4 and 14. 10. This idiot pen is also not working properly. This is 10. And this is dash. 3. Total how much? 13. Your job is not over here. Your job is not over here. Why? What is N factor? Sir, N factor is total number of moles of electrons involved per mole of substance. Per mole of substance. Yes, 13 moles of electrons are involved for 3 moles. Okay. N factor. Let me remind you definition. Number of moles of electrons involved per mole of substance. Okay, right. Now we are having total number of electrons involved are supposed to be 13 and we are having 3 moles. Therefore, we say, sir, we are having something like this, that we are talking about 13 moles of electrons, 3 moles, 1 mole N factor is equal. Go ahead first, try to understand this, then we'll proceed. This is discussion for B bit, right? After that, do it for A bit and tell me answer. First complete this. If you have any doubt, ask and then proceed. Correct, correct. Shall I remove this? It's be acidic salt, salt may be basic salt, salt may be reducing agent, salt may be oxidizing agent. Salt is a general name. A compound is generally called as salt. Wherever you have cation, wherever you have anion, people call it as salt. Finished. But that salt may have different other properties also. Therefore, K2Cr27, just now we have discussed in the previous classes that K2Cr2O7 and KMnO4 are very good oxidizing agents. Therefore, this is oxidizing agent. Okay. If it is oxidizing agent, then the question comes to your mind, sir, what is this fellow is doing along with acid? If it is a base, then I can understand base and acid are enjoying a game in the life. But oxidizing agent and this is acid, right? Then what we have to say, okay, it means to say HCl may be behaving as reducing agent, right? Okay, for that purpose, let us try to understand, is it so? How to check? Chlorine -1 oxidation state. Chlorine -1 oxidation state. No change in oxidation state means it is non-redox reaction. If it is non-redox reaction, then HCl is an acid. If it is an acid, then you are saying, sir, it is an acid. Suppose, for example, if it is an acid, then you have to accept, sir, K2Cr2O7 is behaving as a basic salt. K2Cr2O7 is behaving as a basic salt. So once you are understanding that, sir, I got one chlorine, -1 here, -1 here. So I am confirmed that HCl, some of the HCl, I don't know how many, some of the HCl are acting as an acid. Therefore, it will be acting as a basic salt. Remember that. Remember that. Acha. This is minus. This is also minus. No change in oxidation state. Okay. 2Cl minus, 6Cl minus. Out of 14 HCl, 8 HCl molecules are behaving as an acid. Be careful. Out of 14 HCl, 2Cl and 6Cl, 8 HCl molecules are behaving as an acid. Therefore, they are retaining their oxidation state -1. They are undergoing non-redox reaction. They are undergoing neutralization reaction. Okay, nice. Then this is -1 to 0. Okay, 0. -1 to 0. Loss of electron. Undergoing oxidation. Okay, this is reducing agent. If it is reducing agent, then the neighboring fellow must be oxidizing agent. Yes, sir, I got it. This means to say here everyone is enjoying double role. K2Cr27 is reacting with HCl. HCl says, I want to play a double role along with you. Are you ready? K2Cr27 says, no problem. What are your roles available? I am an acid. HCl says, okay, I will behave as a basic salt, potassium hydroxide, and chromic acid, H2Cr2O7. It is a salt of that one. Next, HCl says, no, I can change oxidation state of chlorine. Therefore, I will behave as a reducing agent. K2Cr2O7 says, no problem. I am well known in the world as a strong oxidizing agent. Right. Now, I am asking the question, what is N factor of HCl? Then we have to find out this with respect to reducing property. How to proceed for that? Out of 14 moles of HCl, you declared that, sir, 8 moles are acting as an acid. Therefore, what we are left out? We are left out with 6 moles of chlorine. We are left out with 6 moles of chlorine. Now, change in oxidation state. How much? -1 to 0. -1 to 0, right? But how many are there? Total, as you said in the previous case, sir, we are having Fe2. Change in oxidation is 1 into 2. Copper, change in oxidation into 2 you have done. Similarly, here also, we are having change in oxidation state. How much? We are having change in oxidation 1. No, sir. There are dash chlorine atoms. 6, right? Out of 14, 8 moles have gone. It is not counting for that one, 6. That means change in oxidation state. What is N factor? Very simple, sir. Change in oxidation state per mole of substance. Okay. 14 moles of HCl. We are having dash 6 moles of electrons. No, sir, I want only 1 mole of HCl. How many number of moles of electrons? N factor is equal to 6 by 14. Answer. Go ahead. Yes. Don't waste time to search papers, right? 8 moles of HCl are like this. Here 2, here 6, total 8. Got it? Shall I proceed? Is it over? Fine. No. Come to the last and fair ball of the game. D. A very beautiful question to understand the concept. Ammonium dichromate. Nitrogen plus Cr2O3 plus 4H2. चलिए, chromium as usual plus 6 oxidation state, we know it very well. Fine. Next one. Ammonium ion. We have done it. Ammonium nitrogen is supposed to be -3. Okay. Then we are having nitrogen here, in this case, 0 oxidation state, chromium +3, and it's over. मोहम्मद शुएब, खैर छोड़िए, बोलना बेकार है, बोलना बेकार है. निहाल, what is done बेटा? What you have done? Mohammad Shoaib, did I ask you to solve that question? What, Nasser? English boy, Nihal Nasser, what you have done? आपको बीमारी है चैट बॉक्स पे जाके पुकारा करने की. How it come error beta? When you are typing DONE, it is how it is coming error. 1000 times I said, please don't go to chat box. On the screen, and overacting. What is the necessity of saying answer? I said D is a question where you have to concentrate. Answer is 12. Please learn how to sit in the classroom, how to grasp. It is not 10th class. You don't know what is the class name which you are attending. In IIT class, we don't want these types of duffer things. Concentrate, simply concentrate, calm and quiet. बहुत से बच्चे बैठे हुए हैं. Most of them are there, calm and quiet. हाँ, answer पूछा मैं आपको बोल रहे हैं. Very excellent, excellent. In between 12, done. What is that nonsense? First of all, you have to understand this. What is the type of reaction we are having here? Which type of reaction we are having? Right? Listen carefully. It's a typical game. It's a typical game. -3 to 0. -3 to 0. Loss of electron. +6 to +3. Gain of electron. Single molecule, two different elements. Single molecule, two different elements are undergoing one loss of electron, one gain of electron. What is this? Sir, we have understood this to be as intramolecular. Yes. It is an example of intramolecular redox reactions. I'm coming individually one by one, case 1, case 2, right? So this is supposed to be the last case left out. Suppose, for example, you are having intramolecular redox reaction, then how to find out the N factor? What is the problem of this question? There is a big problem here. Not a big problem, there's a beautiful problem here in this case. What is that beautiful problem? The beautiful problem here in this case is we are having two elements. One is losing electron, one is gaining electron. Sir, which should we take reference? Which should take difference, right? Right? We are having loss of 3 electrons. We are having gain of 3 electrons, right? Therefore, what we can say, sir, here in this case, we have -3 to 0. Change of oxidation 3. And how many here? 2 nitrogens. 6 electrons are lost. And here in this case, +6 to +3, 3 into 2, 6 electrons are gained. 6 electrons are lost, 6 electrons are gained. Therefore, what happened? Nothing happened, sir. No loss, no gain, no business. Not like that, not like that. N factor is with respect to any one of them, Then the question comes, sir, who is that fellow? I should not take reference any one of them, so that the reaction will be arranged itself in such a way, as many electrons are lost, so many electrons should be gained. That is called intramolecular. Remember this. Otherwise, suppose for example, number of electron lost and number of electrons gained are different. Where the electrons are going out? I think that means you are not obeying law of conservation of mass. Electron is lost, charge is lost. No, not like that. This means to say either you take reference as oxidation process or you take reference as reduction process. Therefore, valency factor here in this case is with respect to either nitrogen or with respect to chromium. Remember that. And both should be same. Both should be same. N factor is equal to change in oxidation state -3 to 0, 3 into 2. This is equal to 6 with respect to which reaction? -3 to 0, loss of electron, sir, with respect to dash, oxidation. Right? No. Let us take this one. +6 to +3. 3 into 2. Sir, it should be, yes, it should be, right? It should be same number, 6 as it is. It should be 6 with respect to which process? Reduction process. Hence, what is answer? Answer is N factor is equal to go ahead. That boy who has given answer 12, he has tried very nice, but that is not the correct method in my classroom, because he or most of you don't know the meaning. For you people, again I am repeating, N factor is number of moles of electrons involved. Where from chromium is getting electron? From nitrogen. To whom nitrogen is giving electrons? Chromium. How can you say 12 here? How can you say 0 here? Are you able to understand? Therefore, concentrate on the wording. Total number of moles of electrons involved. That is the problem, right? That people are not able to understand, because it's not your problem. It's not your problem. Is it over? Fine. If you are sincerely attending the classes and if you are having a rapport with the previous classes, yes sir, I'm having continuous touch with all the things which we have done, then you may be able to understand that we are trying to calculate the N factor. We have done in case of multiple oxidation, we have done in case of multiple reduction, we have taken redox reactions, we have taken intermolecular, we have taken intramolecular also, right? One thing is still left out, that is, sir, how to find out N factor in case of disproportionation reaction, right? See, the way of teaching from the beginning, we fixed a target. I want to find out the concept of equivalent. But when we want to learn that, something new came, we have learned it. Something new came, we have learned it. Till that, we are learning so many new things. Now we are at the end terminal stage of stoichiometry 3. Sir, finally, I want to find out what is the method of finding out the N factor in case of disproportionation. For that, I had to do one more section. I have to learn something new. What is that? Let us try to enjoy that. Next class, in the next parsley, balancing chemical equation for finding out. This is itself is a question. Balancing of chemical equation is independently one question. So I arrange the topics in such a way, the rhythm, the musical rhythm I have arranged in such a way that we are learning a topic. It is itself plus 4 marks question, but it is helpful for our target. Our target is finding out N factor. So balancing of chemical equation. Okay, very good. What is the meaning of balancing? What is the meaning of balancing of chemical equation? Remember that whenever we are using the word balancing of chemical equation, it means to say you have to apply POAC, principle of atomic conservation. That means total number of gram atoms of any element on the left hand side must be equal to that on the right hand side. For example, see one equation on the screen. Left hand side 1 gram atom of nitrogen, right hand side 1 gram atom of nitrogen. This is called POAC with respect to nitrogen. Left hand side we have 3 atoms of oxygen, right hand side we are having 4. No, it is not balanced. It is not balanced. Yes, left hand side we are having 1 sulfur, right hand side we are having sulfur. Sir, sulfur is balanced. This is called POAC. Number of gram atoms left hand side must be equal to number of gram atoms on the right hand side. H2 left hand side, right hand side 5 hydrogen. Sir, this is not balanced. Yes, they will give you this type of equation, and now we are going to apply certain methods so as to balance them. So what is the meaning of balancing of chemical reaction? Balancing of chemical reaction means what your teacher told in 10th class, applying law of conservation of mass. She was absolutely correct. But if you go slightly internal and depth of that subject, then okay, sir, applying law of mass action, conservation of mass means number one. Point number two, okay, sir, I got the meaning of balancing of chemical equation. How to proceed? There are different methods. All those methods are there in your IP syllabus. I'm not going to talk about IP discussion. Come to IIT level or NEET level. In that case, we have one method known as ion electron method. Ion electron method. See the equation on the screen. Ions are available along with molecules. Yes, we have to involve electron also. So if you are involving ions and electrons in any equation for enjoying POAC, that is called ion electron method. Okay, sir, I got it. Next, in ion electron method, you can balance the equation either in acid medium or in basic medium. See on the screen, on the arrow, he has written H plus. Okay, it means say he is demanding to balance this equation in acid medium. That is the meaning of that one. So balancing of chemical equation by ion electron method in acid medium, case 1, in basic medium, case 2. There are 2 cases. Today, let us try to enjoy case 1. Ion electron method in acid medium. Here we are having certain steps. All these steps we have to keep in our mind. In your notes, you have to write this. In IP examination, they will ask to write down these steps also, but we don't require all those things. We have to apply these steps. What is the meaning of balancing in acid medium? Step number 1. Step number 1 is see the reaction, what is given to you, and then make this reaction into 2 half reactions. One for oxidation, one for reduction. How to do that one? Very simple, sir. On their heads, write down the oxidation states and then check up who is undergoing loss, remove them. Who is undergoing gain, remove them. Separately, 2 equations are formed. Therefore, step number 1, prepare 2 half reactions. Find the oxidation states of the elements and identify them as undergoing oxidation or ion reduction, not ion reduction. prepare two half reactions, one for oxidation, another for reduction. Finished. Once you have prepared two half reactions, balance those two half reactions separately. First one, balance completely. Second one, balance completely separate. Okay. How to balance it? What is the meaning of POIC application? Very simple. First, balance elements other than oxygen and hydrogen. Any element other than oxygen and hydrogen. Step 2, balance elements other than hydrogen and oxygen. Very good. Next, balance oxygen. How to balance oxygen? For example, here we are having 3 oxygens, here we are having 4 oxygens. Where you have less oxygens, left hand side, add water molecules. Add water molecules. Balance oxygen by adding water. Balance oxygen by adding required number of water molecules to the deficit side wherever you are having less number of oxygen atoms. Okay, very good. After that, what happens, sir? Hydrogens are getting disturbed. Then what happens? If you add H2O, naturally you have balanced oxygen, but you have added unnecessary those two fellows, H2. Then to balance hydrogen, we have to go H plus. Why? Acid medium. Therefore, balance oxygen by adding, balance hydrogen by adding required number of H plus ion to the deficit side. Step number 4, balance hydrogen by adding required number of H plus ion to the side where you're having deficiency of hydrogen. And after that, job is over. No, sir. It should be charged balance also. No, learn a new thing in your life. A chemical equation is said to be balanced if it obeys law of conservation of mass and law of conservation of charge. Remember, in the universe, not only mass is conserved, you cannot create mass, you cannot destroy mass. Similarly, charge cannot be created, charge cannot be destroyed, charge can be transferred from one point to the other point. Therefore, people say whenever we are talking about this type of discussion, sir, a balancing of chemical equation means we should talk about both, that we are having involvement of, say for example, conservation of mass and conservation of charge. How to balance charge? Very simple, add electrons. Wherever we have more positive charge, add electron. Wherever we are having say for example less negative charge, add electron. Kazim sir? Kazim sir? Kazim sir? Kazim sir? Come on. Wherever we are having excess amount of positive charge, add electrons. Wherever you are having less number of negative charge, add electron, but never subtract the electrons. Never remove the electrons. Assalamu alaikum. Kazim sir? Are you there, Kazim sir? Okay. Step number 5. Balance charges by adding electrons to the deficit side. Jahan pe bhi positive charge zyada hai, wherever we have negative charge less, add up the electrons. And after that, your job is over. You have bifurcated two equations by yourself. Again, join them back so that the whole equation becomes one net equation. That is the last step. What we can say, sir, we have to add up those equations. Fine. Come on. Once you understand this, काजिम सर आप सुन रहे हैं मेरी आवाज? हेलो हेलो सर छोड़िए अपना टाइम. नो प्रॉब्लम छोड़ दीजिए बेटा, अपना टाइम खराब हो रहा है. एक केस करना जरूरी है मेरे को अभी यहाँ पे. चलिए, come to the case 1. First case we'll do here. In this case We'll go like this. Nitrate, this alkane. Okay. First of all, what I should do, I have to identify this is oxidation state +5, oxidation state -2, oxidation state +6, oxidation state -3. जरूरत नहीं है ऐसा करने की, बिकॉज समझ में आ जाता आपको नाइट्रेट को इससे मिलाना है, इसको इससे मिलाना है. दिस विल गेट वंस यू आर गोइंग ऑन डूइंग प्रॉब्लम्स, you will get definitely the idea how to proceed. Come on, first half reaction. Listen and see carefully. Please be on the screen. Don't go to chat box. Nitrate gives you ammonium ion. चलिए ठीक है. Second half reaction is H2S gives you HSO4 minus. First step, prepare two half reactions. I got it. Now balance each of them separate. पहले इसको कर लेंगे. Balance elements. Sequence याद रखिए. Balance elements. No problem. Nitrogen, nitrogen. Enjoy. Balance oxygen by adding water. Okay. Nitrate ion. यहाँ पे ammonium ion. We are having no oxygen. Therefore, 3 oxygen. 3 oxygen means 3 water molecule. Sir, hydrogens are disturbed. No, don't be panic. Cool, cool, right? 3 oxygens. After that, balance hydrogen. How many hydrogens? 4 and 6, 10. Here, nothing. No problem. Calm and cool. Nitrate ion. Plus, we are having 4 hydrogens and we are having 6 hydrogens. We talk about 10H plus ions. Gives you ammonium ion plus 3 moles of water. Nice. Everything is finished. Check up. 1 nitrogen, yes sir. 3 oxygens, yes sir. 6 plus 4, 10 hydrogens, yes. Now charge. This is -1. This is +10. This is +10. This is +1 only. Okay. Now we are having is equal to +9. Therefore, here we have more positive charge. You have to add electron left hand side. Nitrate ion plus 10H plus ion plus how many electrons I have to add? 8 electrons. Gives you ammonium ion plus 3 moles of water. Excellent. Job is finished. Charge is balanced. Elements are balanced. H2S. Now come to second half. Second half, H2S. When we are discussing about H2S, then what we can say, sir, we are having elements, sulfur, sulfur. It is balanced, right? Now let us go for this. Oxygen, H2S, plus how many oxygens? 4 oxygens. Therefore, 4H2 gives you HSO4 minus. Right? Come on. What is balanced? Elements are balanced. Oxygen is balanced. Sir, there is a problem of hydrogen. No problem. 2 hydrogens, and here in this case we have 8 hydrogens. Right? H2S plus 4H2O gives you HSO4 minus. You are asking 8 plus 2, 10. Right? 8 plus 2, 10. Here we are having only 1. 9H plus. Right? Check up. 2 hydrogens and 4, 8. 10 hydrogens. 1 hydrogen, 9 hydrogens, 10. Sulfur 1 available. Oxygen 4 available. Balanced. Charge 0, 0, 0. Nothing is available here. Here we are having +8. Here we are having 9 plus and 1. So +8. So wherever you are having more positive charge, add it up. right, gives you HSO4 minus plus 9H plus 8 electrons. Everything is balanced. But remember one thing, in the examination hall itself, you can say, yes, I'm going to get plus 4 marks if you are getting electron in one equation left-hand side and other equation right-hand side. But not necessarily same number of electrons. Luckily, in this example, you are getting 8 here, 8 here. No. I am not talking about number of electrons. I am saying in one equation, we are having left-hand side electrons, right? That means it is gaining electron. And what is it called? Reduction. And here in this case, we have loss of electron. What is it called? Oxidation. It is known as reduction half cell. It is not half reaction. It is known as oxidation half reaction. Now we have split them. We have done it. Now join them. For joining them, remember, when you want to write final equation, remember, chemical equation is that equation where you are having only symbolic representation of chemical substances. Electron is not a chemical substance. Electron is not a chemical substance. Therefore, we have to eliminate electron. Luckily, in this example, left-hand side 8, right-hand side 8. Therefore, when you add these two equations, in the last step, we have to add equations, and then we get finally both cancelled out. Otherwise, you have to manipulate mathematically to cancel out. Come on. I'm writing here itself H2S plus 4H2O HSO4 minus plus 9H plus 8 electrons. 8 electrons, 8 electrons. 4H2O, 3H2O. Jahan kam hai, wherever you have less, remove that. 10H plus 9H plus. Final equation is supposed to be nitrate ion plus H2S plus H plus ion. Only one was there, now left out, plus water, arrow mark, HSO4 minus ammonium ion plus water is gone, HSO4 minus, H plus is gone, electron is gone. Nitrogen, yes sir, 3 oxygens plus 1, 4 oxygens available, 2 plus 3, 4, 5, 4 plus 1, 5, balanced. Charges, minus 1 plus 1, 0, plus 1 minus 1, 0, plus 4 marks. Go ahead. Allah. Any doubt to ask? Systematically, simply, you have to proceed by stepwise method. Is it over? Fine, that will stop here. Remaining questions available on the screen, that is to be taken as homework and complete that one. I'll remove this. You can take a screenshot of the remaining questions. I'll remove this now first. Take down question number 1, 2, 3, 4, 5. Try to do at home, balance it. Take down screenshot of these 5 questions. ओके उसको एक जगह खरीद करना है तो एक काम करेंगे, इनको खरीद कर लेंगे। स्पेस रखो। चलिए, take down screenshot of these 5 questions. Please try to attempt it. Read the steps. You written the steps in the notes and then go ahead. Take the screenshot of these 5 questions. If it is over, tell me, I'll pack up. Thank you. Assalamu alaikum. electron.